Welcome to Unit 5, Day 5, Quadrilaterals Proofs. In this lesson we're going to be taking a look at how to use properties of different quadrilaterals to write proofs, proving the different parts are congruent or proving other things. And we're going to be going back and using some of the previously learned facts about congruent triangles. So I want you to remember CPCTC. Corresponding parts of congruent triangles are congruent. And remember what we know about parallel lines. And then I also want you to remember things like if the triangles are congruent, their corresponding parts are congruent. So we can use that if we've shown that certain triangles are congruent, along with this page. Okay? So if you have trouble remembering any of your properties of parallelograms, rhombi, rectangles, squares, trapezoids, and isosceles trapezoids, you're going to want to have these notes handy so you can remember those characteristics. So let's go ahead and take a look at our first example. All right, I want you to pause the video so that you can copy down this drawing. Try and get it copied down as best you can. Okay, you do need to recognize that JKLM is a parallelogram, so you can kind of see that I've spaced out JK and LM 2 lines apart on my notebook paper. All right, and JL is a diagonal. All right, I've marked angles 1 and 2. O is where these 2 lines intersect, but QP is not a diagonal. QP just intersects a little bit differently, and it does intersect right there at point O, which is about the middle of the parallelogram. So that's how you can draw that. And then copy down the given information and what it is that we're supposed to prove. All right, if you need any more time, again, like I said, pause the video. Otherwise, let's go ahead and take a look at our proof. So here's what we are given. We are given that JKLM is a parallelogram. All right, and that means all the properties of parallelograms apply. Okay, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals would bisect each other. Now we're not using both diagonals, so that's probably not going to help us with this one. We are also given that JO is congruent to OL. All right, so we know those 2 segments are congruent. And we're supposed to prove that OP is congruent to OQ. So we're trying to prove these 2 parts are congruent. So in order to do this problem, we are going to use these 2 triangles, okay, JOP and LOQ. And if those triangles are congruent, then all their corresponding parts are congruent. So that's what we're going to do in this proof. We're going to try and prove that these triangles are congruent so that their corresponding parts, OP and OQ, are congruent by CPCTC. So we're going to start off with the given information. So I want you to write that down. Okay, you can copy down JKLM is a parallelogram. And then also JO is congruent to OL, all because it's given. We can go back to putting our given information all in one line here. You could split it up, but you don't have to. We can shorten the proof if we combine them. Again, if I'm going too fast through any of this, make sure you're pausing the video so you can copy it down as we go. And now we're going to use these facts to, again, try and prove that these 2 triangles are congruent, so their corresponding parts can be congruent. All right? Now, we have lots of reasons we could use to prove triangles congruent, but I'm going to focus on angle side angle, and I'm going to show you how we know this. Okay? We're using angles 1 and 2. Now, they're not given to us as congruent angles, but remember, we have parallel sides, JK and LM, because it's a parallelogram. And then that makes JL a transversal. So 1 and 2 have to be congruent by alternate interior angles. And then we also have vertical angles here that are congruent. And then the given sides are congruent would make it angle side angle congruent to angle side angle. So that's what we're going to do to prove the triangles are congruent. So the next thing I need to do is state the property of a parallelogram that I'm using, which is that JK is parallel to LM. And our reason is just definition of parallelograms. Okay, anytime we use a property of parallelograms, we can just use the definition of parallelograms. And because those are parallel sides, angles 1 and 2 have to be congruent by the alternate interior angles theorem. Okay, so there's another pair of angles. We have a pair of congruent sides in the givens already. And then we have vertical angles here. So we can say angle JOP is congruent to angle LOQ by the vertical angles theorem. And so I've shown congruent angles 1 and 2, congruent sides that are given, and congruent angles here and here by the vertical angles. So I've got angle, side, angle congruence for the triangles. So I can say triangle POJ is congruent to triangle QOL by angle, side, angle. And the proof statement here, sides OP and OQ are corresponding sides of congruent triangles. So that's why they are congruent. We can say segment OP is congruent to segment OQ because of C, P, C, T, C. And we've proven what we set out to prove. So that's how we can use properties of parallelograms to help prove different things. So let's go ahead and take a look at a second example. All right, for example 2, you're going to want to draw this figure in your notes. Again, pause the video at any time to copy this down. Notice that I've spaced out sides AE and FC with 3 lines. That could help you in your paper. And this is a parallelogram, but also AD needs to be parallel to BC. So do your best to make sure those are parallel lines, and then mark angles 1 and 2. And then copy down the given information. There are 3 statements given, and what we're trying to prove. All right, if you need any more time to copy this down, pause the video, but let's go ahead and take a look at what the proof should look like. We're going to start off by listing all of our givens in one statement. All right, and I'll go ahead and copy this down for you quickly. Okay, and those are all 3 given statements. You can write it like this. And then we're going to use those given statements to try and prove that BE is congruent to DF. And what we are noticing here is with these parallelograms, we get 2 triangles. And once again, if the triangles can be proven congruent, then these parts can be proven congruent by CPCTC. So we're going to use congruent triangles to do that. And so we need to work towards showing the triangles are congruent. And so we are given that angle 1 is congruent to angle 2. We're also given that these are both parallelograms. All right, so I only have 1 pair of congruent angles here and here, and there's no vertical angles to use. So we're going to use other facts about parallelograms. Since this outer quadrilateral is a parallelogram, we know that opposite sides are congruent, which could make AF congruent to CE. And the inner quadrilateral is also a parallelogram, so its opposite sides here and here are congruent. And so those sides of the triangles are congruent also. And so then I could say side, angle, side, congruent to side, angle, side. So that's why the triangles are congruent. So that's what we're going to do next. We're going to say that AF is congruent to CE by definition of parallelogram. And that AD is congruent to CB again by definition of parallelogram. And we've already shown angles 1 and 2 are congruent, which allows us to conclude that the triangles are congruent by side, angle, side. So we can say triangle ADF is congruent to triangle CBE by side, angle, side, which means that the corresponding parts BE and DF are congruent by CPCTC. And that's what we were trying to prove. All right, so this is how we use properties of parallelograms to help us prove things. We also have the properties of rhombi, rectangles, and squares that we could use, and also some properties of trapezoids that we could use in proofs. And so you're going to have an assignment that goes with this. It's very similar to what we've been doing here, but the next assignment will be working on proofs.